This is question 5. You can see it right there. The two-letter permutations of R, S, T, V, X are shown. And so it's a permutation formula where we have 5 elements and we're going to choose 2 of them. So 5 permute 2. And our formula given to us right here says 5 factorial over 5 minus 2 factorial, which is 120 divided by 6. So there are 20 permutations, and there they are. But let's do what we do in the last questions. If we see RS, keep it, and any other combination, that's the right word now, combination of R and S will just erase from our list or cross out. Well, that's it right there. That's all there were. So then RT, cross out, RV, cross out, RX, keep it, cross it, keep it, cross it, keep it, cross it, keep it, cross. And it looks like half of the list has been chosen and the other half have been crossed out or eliminated from consideration because with 2 letters in our string, that's 2 factorial that we're dividing by, right there. From this point on, I really do think you should do question 5 by yourself. I'll work it all the way out, but you should pause the video and skip forward like 5 minutes, okay? That's on you to do. Practice it. You didn't skip forward. What are you doing here? Okay, so we got 4, 3, 2, and 1, which adds up to 12. 12, 10. There are 10 combinations of 5 elements chosen in groups of 2. Okay. And the mathematics in factorial notation is to do 5 factorial over 5 minus 2 factorial times 2 factorial. And that comes up with 10. Let's show the calculator on it, right? So calculate. I've got menu 5, 3, because it's a combination. 5, choose 2. 10. Done. Easy enough. If you want to see the factorial mathematics, this fraction in action, good rhyme scheme for you, then you can go watch another video, watch the previous one. Give me some more views. Let's look at question 6. Use your answers in questions 2 through 5 to complete the table. So make sure you have 2 through 5. Okay, here we go. In question 2, it was 3-letter permutation from 4 elements. So if our n is 4 and we're choosing 3 things, then it was 4 permute 3. 4p3. And I believe 4 permute 3 is 24. Yes. Let me just check that for a second here. So that's 4 factorial on the top divided by 4 minus 3 factorial on the bottom. So 4 factorial is 24, and 4 minus 3 is 1, and 1 factorial is 1. So yes, 24. But then, to get to the combinations, we divided by the 3 factorial. So divided by 3 factorial, which is 6, leaving us with 4. Okay, let's go to question 3. Continuing to build to a formula. That's the whole point of this question right now. Let's build to a formula for combinations. So in question 3, we want 2-letter permutations of 4 letters. Sorry, pointing on the screen. So that would be 4, choose or permute 2. 4 permute 2 is 12. I get that from right there. I get that from the formula right there. We're going to divide by 2 factorial, which is just 2. And we wind up with 6 combinations right here. Here's also the mathematics that we used to get to that 6 value. Question 4. We have 3 things. We're going to put the collection of them into a group of 3. So that's 3 permute 3, which is 1. No, I'm sorry. 3 permute 3 is 3 factorial divided by 3 minus 1, 3 factorial, so that's 6 divided by 1. But we're dividing by 3 factorial again. There's one combination of 3 things written in 3 ways, or of 3 things written in a way. Question 5. Question 5 is up here. A 2-letter permutation of 5 things. So do you see the pattern? Maybe you should finish this row for question 5. See what we did in the previous 3 questions and fill this one out. And then, of course, the answer to this one is 10. But the goal is, how did you get to the 10? So pause, try the rest of this, and then resume, and let's see if we line up in our thinking. 5p2 is 20 divided by 2 factorial, which is 2. Okay. So if we compare the value that we divided by each time to the value of r, so this divided by value, it is r factorial. So that's my answer. It's r factorial that we're dividing by. 73, yeah. I just want to make sure that that's clear, is in the bottom of the combination calculation is a factorial from our number of choices. So if this is in choose r ways, or r things chosen, let's say it correctly, n things chosen to be arranged in r number of spaces, then it's our permutations list divided by r factorial. So formula speaks out as n factorial over n minus r factorial. This is permutation. Let's get some highlight on there. This is the permutation calculation. But then when we divide by r factorial, put that over a 1, and then use the complex fractions flip and multiply method. Reciprocal, reciprocal, those reduce. So then the actual nice factorial formula is n factorial over n minus r factorial times r factorial. All of those pieces matter when we're talking about arrangements of items. I just want to make sure that you are clear on how those arrangements of items can be, used to exist. This has been page 873. Thank you for watching. I'll see you in the next episode.